Okay, so to do that example, we skipped first. So to take an integral of a trig function, like this one, the first thing you should know is that 1 plus tangent squared is secant squared. That is an identity. It's a Pythagorean identity. So the first thing we're going to do is rewrite this one. Oh, why did I do that? That's supposed to be square root of the square root of secant squared x dx. And again, that's just a trig identity. If you check the second page of your books, it's got all of those for you. So then if we continue, the square root of secant squared, those are opposite operations, so they'll cancel out, leaving us with just secant. Square root cancels out the squared. And now if we're doing the integral of secant, that's just using our formula over here. The integral of secant is the natural log of the absolute value of secant of x plus tangent of x. And then if we plug in the natural log of secant of pi over 4 plus tangent of pi over 4 minus natural log secant of 0 plus the tangent of 0. And now this is just using our unit circle. So actually, I think well, over here, let's go ahead and pull it up. So if you grab your unit circle, you can see at pi over 4, secant is 1 over cosine. So it's 1 over our x value here. So instead of square root of 2 over 2, it's 2 over the square root of 2. Which, by the way, 2 over the square root of 2, if you multiply by the denominator to rationalize it, is the same as 2 square roots of 2 over the square root of 4. But the square root of 4 is just 2. And 2 divided by 2 cancels out, leaving us with just the square root of 2. Tangent is y over x. So if you do square root of 2 over 2 divided by square root of 2 over 2, that's 1 minus the natural log. At 0, again, we do 1 over x. 1 over 1 is 1 plus tangent of 0 is y over x. 0 divided by 1 is 0. And there you go. That's where you would leave the answer. Not much else you can do there. If you type that into your calculator, that is approximately 0.881. Where do I want to write that? So again, I'll walk you through this problem. 1 plus tangent squared is just secant squared. That's your Pythagorean identity. If you simplify by canceling out the square root of the squared, you get secant of x. And then to take this integral is just memorizing that formula from the previous slide. The integral of secant is natural log of secant plus tangent. Plug in. To evaluate these, you can either use a calculator and you'll get 0.881, or if this is like a no calculator allowed section, you have to use the unit circle. Secant is 1 over the y value in the units, or x value in the unit circle. Tangent is y over x in the unit circle. All right, so here's another problem for you to try. I would recommend you pause the video here, work on it, and then unpause it to see the results. Here is what you should get. The average value, remember, is found by doing 1 over b minus a of the integral of a to b of f of x dx. So for our problem then, this is a, this is b, and this is f of x. So it'll be 1 over pi over 4 minus 0 of the integral 0 to pi over 4 of tangent of x dx. Pi over 4 minus 0 is just pi over 4. And then your integral here, to integrate tangent, again, we just use the formula. The integral of tangent is the negative natural log of cosine. So then this is negative natural log of the absolute value cosine x from 0 to pi over 4 which gets us 1 over pi over 4 multiplied by the natural log cosine of pi over 4 minus the negative natural log of cosine of 0. Again, you could just type this into your calculator right now. The cosine of pi over 4 is your x value on the unit circle, so it's square root of 2 over 2. So this would be 1 over pi over 4 natural log of the square root of 2 over 2. Minus the negative is really plus. The natural log of the cosine of 0 is your x value, 1. But the natural log of 1 is just 0, right? If you ask what number or e to the what power gives you 1, e to the 0 power gives you 1. So really, final answer would just be erasing this part right here. If you were doing it by hand, or if you're doing it by calculator, to be honest, you could type it in really, you could type it in initially if you use your math 9 button from right here. Or you can type it in right here. And if you type it into the calculator, you should get about 0.441. All right, let's try some inverse trig ones now. So to do the inverse trig ones, the key thing you're looking for is trying to match your integral with which one of these. So for example, if you look at this one, you'll see that it's the square root of a difference of squares. So this is using this first formula, where a for our problem would be 2. And I don't think we have to manipulate that at all. Minus x squared, our u value would be x. But again, we really don't need to change that variable here. I suppose it doesn't hurt. So then if we use our formula, the integral of that is going to be the arcsine of u over a plus c. And again, for our problem, a is 2 and u is x. And that's it. For this one, again, if you look at that, you'll see that that is a sum of 2 squares, or sum of 2 numbers, one of which is a perfect square, The other which isn't, but we can deal with that problem. So we're going to use this second formula. And again, to do this integral, I need to know what u and a are. U squared has to be this. So if I think, if I take 9x squared and square root it, that would be 3x. So u will be 3x. And I do that same trick to find a. If a squared is this number, then if I square root 2, that'll be a. Right? A squared equals 2. Then a equals the square root of 2. If u squared equals 9x squared, then the square root of 9x squared would just be u. And so now I write the formula, 1 over a. So 1 over the square root of 2 times the arctan of u over a. So 3x over the square root of 2 plus c. So again, a lot of these are just identifying what integral they're giving you, which one that matches up with in our formulas, finding out what u and a is, and then just plugging those answers into the formula. So if you try this one, again, pause the video and look to see if you can identify which trig function it is set up for, and then what u and a are. And then hopefully what you should get here is that u squared and a squared are right here. So u squared has to be 4x squared, which means u is the square root of 4x squared, which means u is 2x. A squared has to be 9, which means a is 3. Now we do have a problem here that we didn't have in the previous ones. In the formula, there's supposed to be a 2x, a u right here as well. But I do not have a 2x right here. But I can fix that if I multiply this by 2 over 2. Because then what I'll get is the integral of 2 times dx over 2x square root of 4x squared minus 9. Right, 2 divided by 2 is just 1. So if I multiply this by 1, it won't change the answer. If I leave the multiplied 2 out in front, but I take the divide by 2 and pair that with my x, I now have this in the format that matches my formula. And so now I can write my antiderivative as 2 times 1 over a, which is 3, arc secant of the absolute value of u over a plus c. So again, you identify which formula that matches your problem, find out u and a, and if you need to, manipulate as you wish to get it in the right format so that you can then use your values for u and a to write your formula. All right, we're going to do one more where it's a little bit harder. So if you look at this, this problem doesn't immediately match any of them, right? None of these are a trinomial, like x squared minus 4x plus 7. So what we're going to do to make this match our formula is we're going to complete the square. Okay, so again, if you are good on your pre-calc skills, then you're good to go right here. If not, as a reminder, to complete the square, what you're going to do is you will add b over 2 squared and subtract b over 2 squared into your problem. Where for our problem, our a value is 1, our b value is -4, and our c value is 7. So for our problem, we're going to add -4 over 2 squared and subtract -4 over 2 squared into our problem, which would be, that'd be -2 squared is 4, -2 squared is 4. So we're going to add plus and minus 4 into the problem. And what that will do is get this. X squared minus 4x plus 4 minus 4 plus 7. So again, it'll seem like a really weird step, but you have to take your b value divided by 2, square it, and add and subtract it into your problem. Because the reason why we do that is because now this trinomial here can be factored as a perfect square. If you factor that trinomial, you get x minus 2 squared, right? If you say what two numbers multiply to be +4 and add to be -4, it's the same number twice. It's -2. -2 times -2 is +4. -2 plus -2 is -4. So this trinomial can be factored to a perfect square, x minus 2 squared. If we combine this together, -4 plus 7, that is 3. And now it may not look it, but this actually is in the format of our arctangent formula, where for us, our a value is, again, if a squared is 3, then a would be the square root of 3. And u squared would be x minus 2 squared, which means u is x minus 2. And so this can integrate using our arctan formula of 1 over a, the square root of 3, times the arctan of u over a, x minus 2 over the square root of 3, plus c. Okay? Alrighty. Let's have you try one. Try this one. Again, you will need to complete the square first because this is not in the right format. So again, pause the video, see if you can do it, and then hopefully when you resume, you should get the same answer that I get as I work this out. All right, so again, this isn't quite in the right format. We want, if we have a square root of something squared, we want a square root of a difference of squares, of a constant, and then some function of u. So some function with x in it. We don't have that right now. We don't have a constant term in here. So what we're going to do to complete this is we're going to add and subtract our b value. So our b value here is 3. So we're going to add b over 2 squared, subtract b over 2 squared. So for us, that's going to be 3 over 2 squared and 3 over 2 squared, which is 9 over 4, 9 over 4. So to be honest, you could just leave it as 3 over 2 squared. So then if we rewrite, this becomes the integral of 9 to 4 of 3 over 2. I'm going to put the dx on top. Not that it really matters. Negative x squared plus 3x plus 3/2. Actually, I think yeah, that's fine. 3/2 squared minus 3/2 squared. Okay. I probably, hold on. I'm going to rewrite this. I don't like how I wrote this because the only reason why I say that is because I want to match the formula, which means I want the x squared term to be last and I want the constant to be first. So really, it'll be minus x squared plus, sorry, I don't want to factor yet, x squared plus 3x plus 9/4 and negative 9/4. Maybe I do want to factor first, but okay. Yeah, I do want to factor first. Because I think you have to have you want the positive number in here and the negative in here. This negative is really going to mess you up. Yeah. You should always want the positive term here and the negative term in here, because the fact that our leading coefficient x squared here is negative, and it's supposed to be in the formula negative u squared, then it's going to be a little bit weird, but you actually have to put the negative term next to your trinomial and put the positive term out in front, unlike we did for the previous example. If you then factor this, again, pull out that negative first, might make this easier on you. Then we'll get the square root of 9/4 minus x squared minus 3x plus 9/4. Because now you can see, hopefully, that this is a perfect square. We've actually forced it to be a perfect square. If you say what two numbers multiply together to be 9/4, but adds to be -3, it's gonna be 3/2. So we get the square root, I'm sorry, 9/4 minus x minus 3/2 squared. Again, if you multiply this out, you could check your answer, but -3/2 times -3/2 is positive 9/4, and -3/2 plus -3/2, or basically -3/2 times 2 is -3. All right, if we then identify that our u value is x minus 3/2, and our a value is 3/2, right? The square root of 9/4 is 3/2. We did that over here. Then we can rewrite this with our formula to get the arc sine of u over a from 9/4 to 3/2, which, if you plug into your calculator, is about 0.524. If you don't plug it into your calculator, it's actually not that bad to do by hand. I'll go ahead and finish that if you want to see by hand. If you plug in 9/4 and 3/2 into this, you get the arc sine of 9/4 minus 3/2 over 3/2 minus the arc sine of 3/2 minus 3/2 over 3/2. But 3/2 minus 3/2 is just 0. So this is just minus 0. 9/4 minus 3/2. You need a common denominator. Multiply by 2. So this becomes 6/4. So you get the arc sine of 3/4 over 3/2 which 3/4 divided by 3/2 is just a half. Right? If you like think, how many times does half go into a quarter? Goes into it a half a time. Or if you do work it out, if you're like, huh, what did Mr. Like just say? Divide by your denominator, or sorry, to get rid of these partial fractions, multiply by your denominator, you get 3 over 12 divided by 2 is 6. All right, 4's cancel on top, leaving 3. 3 times 4 is 12, divided by 2 is 6. 3/6 is the same as a half. And then you can evaluate this with your unit circle. You say, what angle gives us a y value of a half? And that angle that gives us a y value of a half is pi over 6. Because remember, this is the arc sine. It's the inverse sine. Right? We take a ratio and we get an angle. Sine takes an angle, gives us a ratio. Arc sine takes a ratio, gives us an angle. So the arc sine of a half is what angle on the unit circle gives us a y value of a half. That's pi over 6. Or 0.524. Okay. So I know that's a bit much. I would encourage you to try to work through the problems. Use Calc chat when you get stuck. If this isn't making sense and you need more examples, look at the AP classroom, look at the Cengage, and we'll do some more for belt work on Wednesday. Have a good one, everybody. If you have run into any problems or have any questions, send me an email.